So this is what we'll be solving for. Our goal is to find all the equilibrium pressures. So our temperature is 45 degrees Celsius. Our Kc is 1.12 times 10 to the negative 6. And this is our equation right here. For A gaseous plus 2B solid goes to and back 10D gaseous plus 5E gaseous. And these are our initial atmospheric pressures. So our first step, what we should do, we should notice that this is Celsius, which needs to be converted to Kelvin. So in order to do that, it's 45 plus, the conversion is 273, which that equals 45 plus 273, 318. So our temperature is 318 degrees Kelvin. And then we have to convert the Kc into Kp because we're working with pressures, atmospheres. So what we can do is set up our equation, which is Kp equals Kc times RT to the power of delta N, which is our change in moles. So let's plug all those numbers in. So Kp equals our Kc, which is 1.12 times 10 to the negative 6, times R, which is, it's given, Mr. Niagara will give us that, 0.08206, times our temperature in Kelvin, 318, to the power of our difference in moles, which is delta N. So 10 plus 5 is 15, and we use 4. We do not use the 2B because this is a solid, and when working with pressures, we only use gaseous and aqueous, so we use our 4. So 15 minus 4 is to the power of 11. And we can plug this in our calculator. Just plug all this in, and you should come out to 4.28 times 10 to the 9th power. And it's 3 sig figs because 1.12, 318, all that. And this is our Kp, which we will be using now. And what we can do is we can do our Qp, which if we set it up, it will be 1.23 to the power of coefficient 10 times 2.54 to the power of 5 over, we do not use solid, this is flat. We use our gaseous, which is 0.91 to the power of 4. Plugging this into the Q, you get 12,000, and 12,000 is much less than our Kp, 4.28 times 10 to the 9. So since our Q is less than, we need to go to the product side, so we will go right. We need to add more products, so our Q becomes bigger. So we would plus the coefficient 10x. We would add 5 plus 5x. This stays nothing since it's solid. And this minus 4x. And then our equilibrium is 0.91 minus 4x dash 1.23 plus 10x and 2.54 plus 5x. Boom. Now we can plug this into our Kp equation, which this becomes our products over reactants. So 1.23 plus 10x to the power of 10 times 2.54 plus 5x to the power of 5. All over our reactants, 0.91 minus 4x to the power of coefficient 4. And we use our numeric solver, go on, math last, numeric solver, and that is pretty much it. And for our Kp, we do 4.28 times 10 to the 9, enter, and we enter that to the E2, enter, make the 0, and we come back, alpha solve, we get 0.16, and since 0.91 sig figs, so we get 0.16, so our x equals 0.16. Now to find our goal, find all equilibrium pressures, So we go the pressure of A, equilibrium, pressure of D, equilibrium, and the pressure of E, equilibrium. We plugged it back into these things. So for our PA, we do 0.91 minus 4 times 0.16. For our D, we do 1.23 plus 10 times 0.16. And for our E, 2.54 plus 5 times 0.16. Let's go. And we can plug all these numbers at 0.91 minus 4 times 0.16, and you come out to 0.27. And what is our units? It is in pressure, which is atmosphere, not molarity, equals 1.23 plus 10 times 0.16, and we get 2.83 atmosphere. And our last one, 2.54 plus 5 times 0.16, and we get 3.34 ATM. And those are our answers. Those are our equilibrium pressures for each of these.